Yeah, Akanksha, you will get it. I'm sorry for the delay. You will get it. Good evening, guys. Thank you. I'm fine. How are you? I don't know who asked it, but I hope you are fine and good. Okay, so there is one information. So first I'll give an information, then I'll start with the class. Not audible? Now audible? Now also not audible. All my strength gone, drained out. Okay, because from 12 I'm continuously talking. Okay, audible? Uh, okay, so first I wanted to give an information, then we'll start with the session. So the information is, so after SQL, Java class will not be there and it will be starting from Wednesday. Okay, Wednesday. I'll take a pic and I'll show to Rohit sir. Now clap once again. Okay, so we'll start. Okay. So today very important topic. So comparatively to all the topics, I can tell that this is little bit lengthier topic. And this topic, whatever we will be discussing today, so this is completely a theory. No practical, completely a theory, but multiple terminologies will be present. So all that terminologies you have to know and you have to understand, because all of them that what we will be discussing will be a very important for your interviews. Okay, so this part whatever it is there, I will be splitting up into the two parts. So first part today I will be completing it because many things you will be understanding it. So second part tomorrow I will be taking. I don't know what is wrong. Audible? Now also it is not audible. Audible? 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 Not audible? Audible? Now audible? Thank you. Okay, so we'll start. So first thing, okay, so listen here. So first thing, that the topic which we will be starting, the new topic is normalization. Okay, so this is the most important thing for your interviews, and this normalization, it will come under your DBMS part. Okay, why? Because how do you manage your particular database here? Here we will have a certain kind of a relationship, all that will be there, but still this normalization, it will be coming under your DBMS part. Okay, but before you start creating the table, before we start inserting the records, a certain process has to be done. Okay, now what is that process and what are the things that, and what is this normalization is all about? This is an interview question. They can ask you that, explain normalization or tell what is a normalization all about. Okay, so understand, I will just repeat the statement. Right now you will not understand the definition, but each and every word that will be included in the definition will be cleared to you guys. So understand, normalization, it is nothing but it is a process of decomposing your tables. Normalization is what? It is a process of decomposing your tables, and also it will eliminate the anomalies. Remember this terminology, anomalies like insertion anomaly, updation anomaly, deletion anomaly. And also it will eliminate the data redundancy. So basically this only we will be telling as what? As a normalization. So normalization is a process of decomposing the tables, and it will be eliminating the anomalies like insertion, updation, deletion anomaly, as well as it will eliminate the data redundancy. If you see in this entire definition, you know and understand only about the data redundancy. But what is anomaly, what is insertion anomaly, updation anomaly, deletion anomaly, you are not aware. And what do you exactly mean by this decomposition of tables also, you are not aware. But you should know each and every terminology, and by end of the normalization, you will get a clarity about each and everything that is included in this particular definition. Now, one small table that I have taken here, and before this, first of all, you need to understand that why you have to go with the normalization. Because why we went for like operator, we have seen. Why we went for functions, we have seen. Why we went for subqueries, we have seen. Why we went for joins, we have seen. Similarly, this normalization also has a biggest functionality. What is that biggest functionality? See, when we have taken a scenario, when the scenario they have given, we know how to convert that into the ER diagram, and we know how to convert into the relational schema, then start constructing a table, we can do it. But what if the people come and give you one raw data they will give? Table is there. You know how to create a table, everything. Now you have to start inserting that records, raw data will be there. Raw data, it is not that always it will be a properly you have to take and organize. So that the data, that whatever it is there, while you are inserting, while you are creating that particular table, a lot of problems can come in the future. So what are those problems and what are the solution for that? So many days what you have seen is just a solution, but you have never encountered with the problems. that what problem can come while creating a table, what problem can come while inserting, what problem can come while updating or deleting, we have never discussed. We have always discussed about the solutions. We have always discussed how to insert, but what problem we did not discuss. So what are the problems you have to be aware? If you know that problems only, properly you can provide a solution, and whatever the tables that you will be having or you will be creating, that tables should be normalized. That table should be normalized, then only that will be called as a standard tables. Whatever tables you got, employee table, department table, that tables are normalized tables. Future, no other problems you will be getting there because those are the normalized problems. So here you will be first trying to understand what are the problems can come. When the problems can come, we will be taking a raw data also. That raw data only we will create a tables, normalized tables, that everything will see. But before we go to that, you need to understand what are the problems can come. So that entire process only, it is nothing but it is your normalization. So whenever you become a database developer, people from the scratch they will expect from you. If they give a scenario, you should be able to convert that into the ER diagram and the schema. If they give you the raw data, you need to be able to normalize that data properly. So here that problems we will be discussing. Fine, so here I have taken a one basic table I have taken here. So here you can see that what and all I have here. I have an ID, I have a name, age, marks and result. Some data that I have given here. I have inserted the record. Now first one if you see I have given all the values. Second one I have given all values. Third one did I provide all the values? No. So this particular student did not take up the test. If he did not or if he or she did not take up the test, I cannot assign the marks here. If marks is not there, can I tell the result? No. So this also will be the null, that also will be the null. Next record if you see, this student also did not take up the test and that is why here I am giving as a null and here also I am giving a null. This is what we have followed. This is what we have done so far. If you don't know the value, just put null. This is what we have done. So whenever we tell here as a null, understand that internally I am leaving a space here to fill up the data in the future whenever the student is taking up the test. I can go here and I can do what? I can update my value here. Till there it is fine. But what if student did not take up the test? Or can you tell it guaranteedly that definitely student will take up the test? I don't know. But what I am doing here blindly, I am giving the space there. It is an empty. But still internally for that cell, a blocks will be assigned. Suppose what if char I used? All blocks are wasted there. I am not using any of the blocks. All blocks are wasted there. So what I am doing here, I don't know the value. See, when I am dumping my every data like this, if one or the other column value, if I am not aware, I am leaving there an empty space. So internally that space will be present. That will be assigned to you. So when it is assigned to you, when I am leaving a space, I need to make sure that I will be filling it later. But there is no guarantee. So don't you think, while inserting, I am leaving a certain space here, 2 students. But when you are dealing with the lakhs together of data, how much of the cells you would have been left like that empty? And internally, some space will be given for that and it is wasted. So being as a developer, whenever you are developing something, whenever you are creating a table, you need to think about your memory storage as well. If you are not thinking about your memory storage, then if you keep on wasting it, you will not be called as a good developer. So whenever you are designing, whenever you are making creation, insertion, you need to focus on your memory as well. Why? Because we are a database developers. For us, the facts and figures, storing is a main task and main role. If we keep on wasting like this, then it leads to the wastage of memory. So while inserting, what I am doing here, I am leaving or I will be leaving a certain space. And that can lead to the wastage of the memory. And if that wastage of memory if I am doing while inserting, basically this only it will be called as an insertion anomaly. Anomaly, whatever I am telling here, it is an IFI terminology. Anomaly means basically, generally if I wanted to represent it, it is a problem. Anomaly means what? It is a problem. So insertion anomaly means what? Insertion problem means while inserting, certain problem can come. What is that problem I am encountering while inserting here? Wastage of memory. So while inserting, if I leave a certain blocks there and if it is leading to the wastage of memory, that we will be calling as what? As an insertion anomaly. So this is a problem. What is the solution for that? Because why I am telling a problem first then solution is because problem only if you are not understanding, solution you can never provide. So that is why you need to understand the problem. Now you got to know what problem you might get. So while creating, remember all these things. If I am creating a table like this, will it lead to the insertion anomaly in future? You need to start thinking. If it is there, you need to give a solution. What is that solution? Is normalizing your table. So basically, normalization means what? Decomposition of your tables. What do we mean by the decomposition? Decomposition again, it is an IFI terminology. So that decomposition, generally if we have to tell, we have to split up that particular table. So here what I am doing, I am giving a student detail also, I am giving the marks result, everything I am dumping where? I am dumping in one particular place only. I am dumping everything in one particular place. When I am dumping this, that is when that I am getting that particular insertion anomaly. So instead of what I will do, I will decompose my table. Decomposition in the sense splitting up your table. So what I will do, I will take up the other table like this. This one, see, first of all, you should not create a table like this. Understand, if you are creating a table like this, you will be getting a problem. That is why you have to create a table like this. So this one only what I am doing here, I am thinking if I am creating this problem I will get. So what I will be doing, in one table I will take ID, name and age. And this one I will make as what? As a primary key. In other table what I will be doing, I will give that marks and the result. So right now here, I don't know which student got that particular marks and result. So to get to know that, what should I do? Create a relationship. So whatever ID I have here, that ID I will be taking there and that I will be making as what? As a foreign key. So there that particular values, that which student has got that particular 80 marks. Who got 80? 101. 80 who got? It is 101. Next, 70 who got? 102. So this is how that I will be creating that particular relationship. 101, 102. So what I can do here is, tell me right now, anywhere I am leaving an empty space here? No. Now, suppose student information also I have. This student did not take up the test, that is why that information is not present there. This student did not take up the test, that is why that information is not there. Suppose in the future, anytime, Ramya took up the test. Can I come to this table, tell here 103, this is a marks and this is a result? For this, should I leave a space? No. So am I getting any wastage of memory here? No. So whenever you are dumping every data in one table like this, if you are creating, think, will you get any insertion anomaly here? If you get a thought, no, I will get it, don't create like that. Split up into the two, decompose into the two or three and create that particular tables and create a relationship. And decompositions only that we will be technically called as what? As a splitting. So normalization is all about, if you are encountering a problem, if you think this problem will come, decompose, normalize. Normalization is all about the process of decomposing your tables, means splitting up your tables. So when I thought I have to create like this, I got a thought no insertion anomaly will occur. So what you have to do, you should not create a table like this, you should create a table like this. So here that insertion anomaly you will not be getting it. Again, ma'am, you said this table decompose, for that don't create this first. Then tell I get decomposed into two. This is a problem. I am telling you should not create like this. You should create like this. So segregate your data wherever you feel that problem will come and make a relationship. Whoever takes 104 is taking first, come here, tell 104 what is the marks, what is the result. Insert the record. Anything is getting affected here, any information you are missing here, and tell me, is there any data redundancy here? Any data redundancy here? Data redundancy also is not there. What do you mean by data redundancy? Repetition. I don't have. Properly I have a primary key here, properly I have a foreign key here, every information is present properly. So if you see here, basically in these two particular tables, I don't have a data redundancy also and I don't have the insertion anomaly as well. So this is how the tables that whatever you are creating, you have to normalize them properly. So from the definition, did you understand what do you mean by process of decomposition? And what is anomaly? What is anomaly? Problem. Insertion anomaly in the sense? Insertion problem. So you have to explain properly. While inserting, if I am leaving any space, if it is leading to the wastage of memory, so that time we tell that there we have an insertion anomaly. So for that the solution what it is? Normalization, decomposition of your tables. I hope this terminologies you understood. Decomposition, anomaly, insertion, anomaly, and even the data redundancy as well. Fine. So similarly now you need to understand about the other anomalies that which we have. Now this example I have taken here, okay. So here student information also is there, if you see course information also I have here, both I have here, okay. Now I have there 101 it is an SQL and 102 it is a Java, I have that particular information. Now my requirement I have. So what is that requirement here basically is, wherever SQL is present, I want to modify that or I want to update that as a SQL. Did you understand? Wherever SQL is there, I want to update that as what? As a SQL. Now, we know that in our MySQL, data which is present inside the table is not case sensitive. Whether it is in uppercase, lowercase, one query if you are writing everywhere, it will get updated. But when it comes to Oracle, data which is present inside the table is case sensitive. Uppercase, lowercase, everything matters in the Oracle. So when you go to the interview, they will not tell MySQL only you give, Oracle only you give, they will not tell. So you need to be prepared with everything. That is why I said you, whenever some data is given in the question, give it in the same manner. Because you don't know whether their intention is to give on the MySQL or on the Oracle. So, with respect to the MySQL, SQL both one query, I can completely update it. In the MySQL only, suppose the cases are different. SQL only cases are different. Still in one query only I can do it. But assume that cases are different and they are expecting you to do it according to the Oracle. How many queries you have to write? How many queries you have to write? One query only, you can tell OR. And again you can tell course name equals to this. But if there are multiple combinations, every time will you sit and tell or this, or this, or this? If you are missing one also, don't you think that it is a wrong data that you are having? For one student as a SQL, for one student an SQL, are you maintaining that a proper or a structured data there? No. So here I want to update one data. For that data only, that query multiple times I have to repeat if it is case sensitive. If I am missing one also, there will be a mismatch. That uniformity will not be maintained. But we have to maintain that. We cannot tell for one student SQL, for one more student SQL. We cannot keep like that inside our table. So basically, this kind of a problems only are called as an updation problems or an updation anomaly. Same data only, updating it multiple times. Suppose if we have that cases issue, MySQL we don't have, but we need to think about in the general. Why? Because I am not talking now with respect to only RDBMS. I am talking with this with respect to the DBMS. So I need to think in the all the perspective way. So in that case, I have to keep on updating with the things. So as I said, suppose SQL, I need to do it as what? As a SQL. So next, one more SQL it is there. So this also I wanted to update as what? As a SQL. So generally if I am talking 2 times I have to update. I am thinking in all perspective. Again I am telling, I am not talking only with respect to MySQL here. I am thinking about all perspective. So 2 times I need to update. If one more is there? If one more is there? So how many? Can you see the count will be increased if I have a multiple students here. So this is a problem. So what is the problem here? So what is the problem this is? This is an updation anomaly. And what is the solution for this? Normalization. So normalization means what? Decomposing of your tables. Now whatever the table that I have here, I can decompose it. So what I will do in one table, I will take like this. I will take here ID, name, age, all the things I will give. In one more table, what I will do, I will keep my course details here as course ID and course name and the rest of the data that whatever we have here, that data again. If you see here in this course ID, don't you think that I have a data redundancy? I have a data redundancy or no? When I am decomposing, I can make this as a primary key. And should I tell 101, 101 multiple times? No, I can only tell 101 and SQL. Then I can tell as what? 102 and Java. And this I can make as what? As one separate table. So now, do I have any relationship here? I don't have any relationship. So I can create that particular relationship by taking a foreign key. See? I created a relationship. I have decomposed, created a relationship, which student has taken up which course, everything I have. My requirement is still same. SQL I wanted to update as a SQL. Maximum, how many times you will do here? However you see, it is only once. Because only here is where I have given it directly. Tell me, here if I am updating as a SQL, anywhere it is getting affected in any other table? No, because ID remains the same. ID will never change. ID remains same. That ID is what is present here. But what I will be changing here? Only whatever the SQL is present here, I will be changing that as a SQL. So here I need to write up the query only once max to max, and I no need to worry about the case sensitive part. And I no need to worry about that what if I miss some. So this updation anomalies should not be present inside your table. So same data only multiple times you should not update. If you are updating it, it should be updated only once. That is how the data has to be there. Same query multiple times if you are executing, if you are writing it, then it's not efficient. And it is not standard also. So this is only we will be calling as what? As an updation anomaly. Means inside a table, same data only, same information only, updating it multiple times. We tell that as what? As an updation anomaly. And what is the solution for that? Normalization. And here if you see, tell me, do I have a data redundancy? Do I have an insertion anomaly? Do I have an updation anomaly now? No. Here, in this table, do I have updation anomaly? No. So like that, whenever you are creating, make sure everything you check. Check for data redundancy, check for the insertion anomaly, check for updation anomaly, check for the deletion anomaly as well. And check for the data redundancy as well. So this is how you have to check, and then only if none of these things are there, then only you can tell that your tables are normalized. Otherwise your tables are not standard. Definitely in the future problem you will get it. And again you have to sit and write that multiple things again and again. Again, this is everything can depend on the raw data. You should never expect that raw data will be in a proper way. That is why it is called as a raw data. So from the Excel directly they will pick and they will give create a table and insert. So being as a developer you have to think it properly and you have to do. Why? Because sometimes data will be generated automatically. So you have to take that, you have to make a proper format, normalized, and what you have to do? You have to do up the things. So this is only we will be calling as what? As an updation anomaly. So what is an updation anomaly? Updating the same data multiple times. Solution for that is normalization. So in that problem should not come. So this is how that you have to create and structureize your particular tables. Fine. So next let us see. So same table only I have taken here. Okay, same data I have taken. Now, this is a table assume. Now, this is student Ravi 103, whoever is there, assume that he has left the TAP Academy. Okay. When he leave the TAP Academy, from the main backup will keep. Backup we will be having. But from the main database we will remove. Why? Because it will again, that also will occupy a memory. That also will be occupying what? Memory. So what if the student has left or got placed? So I wanted to remove that particular student detail. I removed. One student detail I removed. Now, when I removed that particular student, don't you think that I have missed one information? What is that information I have missed? What information I have missed here? Course, not ID. It is a course name and ID both. Why? Because Java he has taken. Java he has taken. Now I deleted student information. Do I wanted to delete a course information also here? My intention was to delete only the student. Suppose if someone comes and asks, show me what are the courses that you are doing in the TAP Academy. If I show this detail, How many courses they will think? Only one. But that is not the true information, right? So sometimes what happens is, whenever you are deleting a certain information, knowingly or unknowingly, some other data also, if it is getting deleted, which is important, that is called as what? That is called as an deletion anomaly. If you are deleting one record, only that it should get deleted. It should not affect the other data. Along with that, other data should not get deleted. Why? Because each and every data, it is important. So this kind of a problem only, it is called as what? It is called as an deletion anomaly. So while deleting any data, knowingly or unknowingly, some important data also if we are losing. So then that problem is called as what? As a deletion anomaly. Okay, so this one is that. So what is the solution? Decomposition. So I will bring up the data here like this. Okay, and here also I will bring up the data here. Course ID and course name I will bring here. So I will make that as a primary key there. So repetitions also will not be there. So here I can tell as what? As 101 is for SQL and 102 for Java. So this one I can create up like this. So here what I can do, creating a relationship, I can take a course ID, I can do what? I can do a foreign key here, create a relation. So which record I wanted to delete? Which student information? Ravi's information is what that I wanted. So if I remove that Ravi's information, any other data got deleted? Any other data got affected? No. So this is how that you should have that proper tables here. Tell me here in this table, do I have a data redundancy? Do I have an insertion anomaly? Do I have an updation anomaly? Do I have a deletion anomaly here? Here. No. So this is how that whenever you are splitting, on these things you have to check. On these tables, do I have any anomalies or do I have any data redundancy? So whenever you are creating, you need to think about all these particular problems. All these problems you have to remember. For all these problems, what is the solution? Normalization. So you should never think about creating a tables like this. And this problem most of the times you will get if you are dumping every information in one place. If you try to dump every information in one place only, most of the times you will get that problem. When you segregate, when you keep it properly, all the problems will not be coming. So that is why we do in our MySQL, segregate data, keep it in the different and create up the relationship. So this is how, now if you see, normalization is the process of decomposing and eliminating the anomalies like insertion, updation, deletion, and also it eliminates the data redundancy. Now did you understand the definition? So this is how that normalization that you have to perform if they are giving you the raw data. Again I am telling you should not go and create this and tell later I will decompose. No. You should not create this, you should create this. You should think, if I create like this, I might get that problem. So that is why you have to create it like this. So this is how that any raw data which they have given, properly you need to check that. If you see in every table here, we will be having that primary keys, foreign key, means relationship, data redundancy will not be there. Any other problems that you will not be getting here. Wastage will not be there, loss of data will not be there. So updation problem should not be there. Then only we should consider the tables as a standard tables and tables as a normalized tables. So this is how that process that will be present. So what and all the terminologies you have seen? Decomposition, anomaly, insertion anomaly, updation anomaly, deletion anomaly, data redundancy. Apart from this, we have other important terminologies as well, which where still if you see, we have a types of normalizations also. But if you have to go till there, you have to know all the terminologies. You have to know all the problems. Problems are done. But apart from this, there are certain other terminologies also which you should be aware. So basically, what are those particular terminology in the sense? I am taking one variable here. Okay. So one equation that I am providing here. Tell me, how do you consider this particular equation? X tends to Y. So this is how that usually that we will be pronouncing generally in terms of the mathematics, all that. Okay. Now, when it comes to here, when it comes to the database, when it comes to the DBMS, we need to tell that X and Y both are the attributes. Means both are the columns. X and Y is what? It is a attributes, or those are columns. Whenever you are having this expression like this, you need to tell that this particular attribute is determining this particular attribute. What it is doing? X attribute is determining the Y attribute here. So, and in other words, you need to tell Y is functionally will be dependent on your X attribute here. So probably directly you might not understand like what exactly this representation, what do we exactly mean by determinant, or what we exactly mean by functionally dependent, all that probably you might not understand. So let us take one proper example. This is a syntax basic thing. So here X and Y you have to consider as what? Attributes or the columns. So X is determining Y and Y is functionally dependent on the X. That is what this equation tells according to our DBMS. So now as an example, that if you are taking ID is what? It is an attribute. ID is what? It is an attribute. ID can determine your other attribute. For example, if I am taking a name or if I am taking age, can determine. By keeping your ID, can determine your name. I can determine your age. I can determine your gender. So ID is what? ID is determining name. Name is functionally dependent on the ID. So this is what that determinant means. So what do you mean by determinant here? What do you mean by determinant? Determinant means you are telling ID. What is determinant, I am asking? Any attribute which identifies or which determines the other attribute. We call that as what? As a determinant. In our example, ID is a determinant. Why? Because ID determines or identifies the name. And this one uniquely no use. This one individually no use, because repetitions will be there here. By keeping that name, I cannot identify anything of yours. I cannot tell age. I cannot tell gender. Why? Because multiple things can be present. Duplicate values can be present. So, a unique thing that whatever we have only we can consider as what? As an determinant, which determines the other attribute. And the name will be functionally dependent on what? On the name. So, two statements I will tell. Remember these two statements. All determinants. You understood what is a determinant? Which identifies something, which determines something. So, all the determinants cannot become a key attributes. Why I am telling this, you will understand in next example. But understand, all determinants cannot become keys, key attributes. But all key attributes will definitely be a determinant. Remember these two particular points. All determinants cannot become a keys, but all the key attributes can become a determinants. So remember these 2 points. which you will understand in the next example. So here this is what I am taking. Only columns I have taken here. What and all I have taken? Only the columns I have taken. Now employee ID, employee name, employee age. See, initially they will not assign you directly anything. Something called as a training period will be there for you guys. So that time they will assign you what is a course that you have to get trained, or what is a technology that you have to get trained. That will be assigned. So that is why here I have taken a course ID and the course name. Don't tell, ma'am, employee you are taking a course. How does? Initially, every employee will be assigned a technology to get trained up. So that is what that I am taking here. Now, in this, identify the determinants. Employee ID, course ID. Then, employee ID and course ID, that's all. What is determinant? Which determines other, right? Now, yes, employee ID can determine what? Employee name. Course ID can determine your course name. If you see at last, without a marks, can you tell a result? Marks is what determines your result. So marks also is what here? It is one determinant which determines your result. Which determines what? Your result. So here employee ID is one determinant and course ID is what? It is one determinant. At the same time, even your marks is what? It is a determinant. That is what I said. All determinants cannot become keys. In this, tell me, all determinants can become keys? No. Marks is a determinant, but can I make that as a key? A student, 2 to 3 students can get the same marks. So I cannot make that as a key. So that is why I said you that point that all determinants cannot become a keys. But all the key attributes can become a determinants. So tell me how many key attributes we have here? 2. That is course ID and the employee ID. Both are determinants? Yes. So all determinants cannot become keys, but all keys will definitely be a determinant. I hope now little bit more information about the determinant you have understood. Fine. Now, from this only I will be picking few things. I am not taking entire thing, so don't get confused. I am just taking up the scenarios, I am just picking up the things here. Now, here I am taking employee ID. This is very much important. This is very much important. Please do focus. There is a chance that you can get confused, so please focus. Employee ID I have taken and I will be taking here the course ID. Okay, employee ID, course ID I took. At the same time, I will be taking here employee name also, and I will be taking employee age also, and I will be taking the course name also. Consider this is one table. Consider this is one table. Inside the table, what and all I have? Employee ID, course employee name, employee age, course name. This is what I have inside my table. This is my table. Now, in this, which are the key attributes? Employee ID and the course ID. I cannot make individual as a primary key, but I can make them as a composite primary key. So for me, they are key attributes. Okay, now, this employee ID determines what? Employee name. Yes, employee age. And then, it can determine the course name also. By keeping an ID, we can also tell that which course you have joined, which course you have enrolled. I can easily tell. So, employee ID is a key attribute. I am not talking about determinant here. Forget about the determinant is done. It's a key attribute. Yes, ID, employee ID is a key attribute. That is determining employee name, determining employee age, determining the course name. Now, whatever employee ID, course ID I have, these are the key attributes. But whatever the employee name, employee age and the course name I have, these are the normal columns. Employee name, age and course are what? Normal columns. They are not the key attributes. Key attributes are only employee ID and the course ID. Now, this key attribute is determining all the common columns which are present inside a table. Yes, a key attribute, one key attribute is determining all the common columns which are present inside a table. Correct? Yes. Now, we'll go to the next key attribute. By keeping a course ID, can I tell employee name? Can I tell an employee name? No. Why? Because multiple students can have this join in the same course, means same course ID only will be there. By keeping that, how do I identify the employee name? I cannot. If name only is not possible, age also it is not possible. But by keeping a course ID, can I determine the course name? Yes. So by keeping this course ID, I can determine a course. Now, inside my table, I have two key attributes. In that, one key attribute determining all the common columns that are present inside a table. But one more key attribute, it is not determining all the common columns which are present. If this is a case inside a table, then we tell that inside this table we have a partial dependency. Whatever the key attributes we have, every key attribute individually should identify all the common columns that are present inside a table. If it is not identifying, in this case, yes, it is identifying, but in this case, it is not identifying. This scenario we can have, but if we have what we have to call this as, that we have to tell that inside this particular table that what we have a partial dependency. So this terminology is very, very much important. So what is partial dependency in the sense? If all the key attributes individually, if they are not identifying all the common columns which are present inside a table, then we say that inside a table we have a partial dependency. So any table like this, you have to tell there is a partial dependency. Remember this terminology, important. Fine. So next year, this table is done. Now one more example I am taking. Okay. So here I have taken a marks. By keeping this employee ID, can I determine his marks? Yes, I can determine his marks. And by keeping this course ID also, can I tell the marks? When I am creating a relationship, yes. When I am creating between every table, I can have what? I can have a relationship. And one more thing here, getting a marks of that particular student only is not sufficient. In which course he got that particular marks also it is sufficient. So whenever we are creating a table, we will be creating in such a manner that student, which marks and from which course that he will be getting. So that connectivity will be present inside a table. Why? Because only marks, if you know of the student, no value. On which course he has got or she has got, that also is important. So that connectivity will be made here. So here, which student has got this particular marks and from which course he has got that particular marks will be there. And if that information is not there, what is the use of having only the marks? You have Java, you have SQL. You have Java and you have SQL. So by keeping only, suppose here I will tell in 101 he has got this particular marks. By keeping that ID that I can tell, right, in 101 you got this marks. In 102 you got this particular marks. I can tell that marks. Based on what? Based on that course ID here. In this subject, how much you got? In this subject, how much you got? We can easily tell. So I have a marks, I have a course ID. That course ID here again, this can be foreign key also, but key it is. This can be what? This can be a foreign key also, but still it is a key. Yes or no? Still it is a key. So by keeping this employee ID also I can determine the marks. By keeping this course ID also, when I create a relationship, by keeping that foreign key, in this course only you got this marks. In this course only you got this mark. I can tell. Whether it can be a primary key or whether it can be a foreign key, but it is a key. So in this case, tell me, consider only this much. Consider this only as a table. Leave about this. This is done. Now, in this table, tell me how many key attributes I have. 2 key attributes. What are those? Employee ID and course ID. How many common columns I have? Only 1 column I have. In this particular table, each key attribute individually identifying the common column. Yes or no? Yes. So, whenever inside a table, all the key attributes, if they are individually identifying the common columns which are present inside the table, this only technically we tell it as a total dependency. So tell me, what is partial dependency in the sense? So all the key attributes individually, if they are not identifying the common columns, we tell that as what? As a partial dependency. If all the key attributes individually, if they are identifying the common columns, then we tell that as what? As a total dependency. Did you understood the terminologies? What is partial and what is total? I have just picked up some columns and I gave as an example. So consider this as an individual table. Don't think, ma'am, this also is, no, only this I am telling you to consider. So inside a table, if this is a scenario, then you have to tell that as what? As a total dependency. So we have one more important terminology which you should aware. Now, I am taking here the result. I am taking here the result. Okay, now, this result is determined by whom? Marks, correct? Without a marks, I cannot tell what? I cannot tell the result. So, marks is actually determined by the marks. And this marks, consider this entire thing. Marks is, result is determined by the marks. Marks is determined by the other attributes or the key attribute. So, in this entire thing that if you are seeing here, one attribute is determined by the other attribute in turn, that is determined by the other attributes. So whenever we have this kind of the scenario, then we tell this as a transitive dependency. What we tell this as? Transitive dependency means one attribute is determined by other attribute, in turn that will be determined by some other attribute. So we tell this scenario as what? As a transitive dependency. So these 3 terminologies are very, very much important when you go to the types of normalization. Whenever you take up the raw data, this is very, very much important, and even in the interviews, they will ask you, what is partial dependency? What is total dependency? What is transitive dependency? If you are telling orally, definitely they will not understand. You need to take up the examples properly here and you have to represent them properly. So what and all terminologies we have seen so far? So far, decomposition, anomaly, updation and partial dependency, total dependency, transitive dependency. So all these terminologies in this, all the terminologies are important for your interviews, and in this only the few terminologies are important when you are actually performing the normalization on the raw data. Whatever we have taken, we have took and table examples, but table will not be there, raw data will be there. That raw data only you have to normalize it properly. Fine. So before we see that what are the type of normalization, raw data, everything, I hope these terminologies are clear to everyone. Yes? So I'll stop here for today. Okay. Revise the terminology and come for the next class. Fine. Thank you everyone. Thank you all.